In this video, we look at how to obtain the maximum number of outputs from baseline PICs and consider some of the issues that might arise. We will look at the PIC10F 200 series. This is an ideal example of a very limited pin count device. The PIC10F is available in a SOC23 6-pin package, as well as an 8-pin DIP package. With the 8-pin DIP package, only 6 of the pins are actually active. 2 of the 6 pins are power pins, with the remaining 4 pins for I/O, where 3 pins are configurable for either input or output, and 1 pin is configurable for input only. The input only pin on GP3 has an internal weak pull-up that's configurable, so you can switch that on and off within the code. It's possible to exploit this feature by adding an external transistor, effectively creating a fourth output. Using an FET with a low gate turn-on voltage, it's possible to create an open drain style output where the internal pull-up drives the gate of the FET to create the on state, and as shown in the diagram, a 1 megohm resistor pulls the gate low when the internal pull-up is disabled. For 5-volt operation, a FET like the 2N7000 would seem to be ideal. For lower voltage operation down to, say, 2 volts, a bipolar transistor would probably work more effectively. The circuit shown here is one that I've tested down to 2 volts using a red LED with low VF, a low forward voltage. Strictly speaking, the 4K7 base resistor is not actually required, but is essential if you intend to in-circuit reprogram the device, as obviously you wouldn't want to apply the programming voltage directly onto the base of the transistor. So using the methods described, this is an example of a 4 LED sequencer. The code for this example was written in C, but you will notice that there are a couple of lines which are in inline assembler. The reason for this is because the option register, which contains the enable bit for the weak pull-up, is not defined in xc.h and is not easy to get to from C code. So in this circuit, we've effectively rendered the master clear line inoperative by configuring the pin as an input. What we've also done is configured GP0 and GP1 as outputs. So these 2 lines are also the in-circuit serial programming data and clock lines. So some care needs to be taken when reprogramming. GP0 and GP1 need to be tri-state before programming commences. I have had issues in the past where this has not been achieved and the device has been damaged or corrupted. One of the most reliable methods I've found is to allow the PIC3 to control the power, so remove the external power from the board, and using the settings shown, I've not had any issues. In this example, we took advantage of the fact that there's a weak pull-up on the GP3, the not master clear line. This seems to be a feature that is perhaps peculiar to the PIC10F. I've noticed that this feature is not available on the PIC12F. I looked at the 629, the 675 and the 683. So perhaps if you intend to apply this solution, you take a careful look at the data sheet first.